Perhaps these cartoon images could be Professor Hume and Ivy. All right, we're working with the accelerometers. First couple of questions here. Number 1, what can change the speed or direction of an object? Well, that would be forces. A force can change the speed or direction of an object. Number 2, what is the force which resists motion between two surfaces in contact with each other? Probably remember that from earlier science courses. Friction. 3, what is caused by unbalanced forces? This is a terrifically huge concept for this study guide, and that would be acceleration. Acceleration is caused by unbalanced forces. Your accelerometer is designed to test for unbalanced forces, so the accelerometer is designed to test for acceleration. Do not allow your accelerometer to fall off your lab table. Now I'll be doing the movements with the accelerometer, so I'll be sure to not have them fall off the table for us. Now, an accelerometer is an instrument that is used to detect acceleration. When we have a container, and they can be pickle jars, mayonnaise jars, baby food jars, we have some beakers that are plastic that we'll use. You can put a paper clip in there, so a pendulum. A little quick review pendulum. Remember, you measure the pendulum's length from pivot point to center of the bob. The position the pendulum is in right now is the equilibrium position, and the mass at the end of the pendulum, that paper clip there, is the bob. And you can also use accelerometers inverted, where you have, and we fill these with water, by the way. We're trying to increase the friction to be able to slow the motion of that pendulum, to better see that movement when the accelerometer is basically screaming at us saying, accelerometer, acceleration, acceleration. There's been an unbalanced force. You can use them inverted. Sometimes a table tennis ball or large paper clip can be used, and these are the high piece of equipment, technological advancement that is used today in the car industry to sense vibrations, acceleration, unbalanced forces in vehicles in efforts to improve fuel efficiency. For the 2 pages in your study guide, we have scenarios A through E. For each of those, you're going to draw 4 things. You'll be sure to identify any unbalanced forces and describe 4 things about the accelerometer.
I'm so sweet. I'll do the first one for you. Accelerometer at rest.
We now need to draw a diagram with these 4 components. The accelerometer, just the basic shape here. Let's maybe have a pivot point connected. Paperclip is drawn. Applied force. Well, there was no applied force. It was just sitting there at rest on the dry erase marker board. An opposing force. There was no opposing force. It was just sitting there. Force of gravity, always pulling things straight down towards the center of the earth, gravity. We also need to describe how the paperclip moves in response to your actions. Well, it didn't. 2, type of acceleration the accelerometer is experiencing. None. 3, major force which caused the accelerometer to start moving. None. 4, major force which caused the accelerometer to stop moving. None. I'm so sweet to have done the first one for you.
Letter B is observing the accelerometer as you start the motion. So just what that paper clip is doing at the start of the motion.
This snapshot should give you a good indication of position of that paper clip at the start of the motion, this being equilibrium. So we'll leave it to you to draw the sketch of where the paper clip is. Well, leave it to you, but I just showed you. We'll leave it to you to draw the other 3 items. And we'll also leave it to you to describe those 4 components.
C is observing the accelerometer as it comes to a free sliding rest, so at the end of the motion. So watch the paperclip at the end of the motion. Do it again, end of the motion.
And a freeze frame here, paperclip, as it came to the free sliding rest. Draw your 4 items, or label the 4 items on your diagram. Describe the 4 things asked for there. Letter D is observe the accelerometer at a constant rate, moving in a circle. So I'll try and move this in a circle and not make it go faster or slower as I make this circular path. Bit dizzying and raucous in sound. We'll see if the slow motion helps a little bit. Slightly better. Alright, to help you with this particular drawing, it's probably best to draw from a bird's eye point of view. We got an accelerometer at various positions in the circle, and it's very difficult to see, but the paperclip does actually swing to the outside in that circular path. So an applied force. And the applied force is greater than the frictional force, the one that opposes the motion. So I'm going to make that arrow smaller. Larger force vector, smaller force vector. So this is a greater force. So the applied force greater than the frictional force. And if you think about this, we're trying to physically demonstrate for you how you can have something moving at a constant speed, yet there is absolutely still acceleration. This paperclip is letting you know, hey, there's acceleration, and there's acceleration because there's a change in direction. There's a change in direction. So we have displacement. So we have a velocity change. And we'll have you describe those 4 items. Letter E is observe the accelerometer as you move it across the table in a straight line at a constant speed. Maintain continuous contact with your hand and the accelerometer. So moving in a straight line, I'll just start it over here, give myself more room. Moving at a constant rate. So letter E, I have a constant rate again, but I'm moving in a straight line. So there's no acceleration. There is motion, there is movement, that constant rate, but because I'm moving it in a straight line, that accelerometer does not indicate an unbalanced force, does not show acceleration. Make the diagram. Answer those 4 items. And we'll wrap this up with items 1, 2, and 3. 1. List 2 controls in a car which cause a change in speed. I would say you probably have your accelerator pedals, gas and brake to be specific. Which control in a car, apart from these listed already, can cause a change in velocity? Well, what's left is your steering wheel. Number 3, in a well-written paragraph, and I will include in the module listing for this a little guide for writing a good paragraph, you're going to compare 3 instances when a change in velocity can be observed when you're either driving or being a passenger car with your accelerometer. So you're going to describe 3 instances where you have a change in velocity in a car and the 3 changes in velocity you saw with your accelerometer. Be sure to include in your paragraph a description of the forces, and you already have those written down in the A through E. It's partly why I had you do that, which cause these changes. And be sure to include what the rate of change in velocity is called in your paragraph.